Hi, we will start the session in 5 minutes. We will wait if someone wants to join. Is that okay?
Okay, ma'am.
Okay, thank you. Hi, Pavitra. We will wait for 5 minutes. At 9:35, we will start. Is that okay? Thank you. Okay, I think we will start the session because I don't think any more people are going to join. So I will start the session. Okay, so let me share my screen. Mm, okay, so hi everyone, I'm Shivashankari. So I'm a NPTEL TA working for the course wastewater treatment and recycling. Today will be the fifth live session, and in this entire week, the professor had thought about the design of treatment units, especially until the primary sedimentation tank. So, today I'll be handling the doubt clarification session. I have few problems and a few theoretical questions to solve. So, we will start proceeding with the session. Okay. So, first thing is, let me share my iPad. So in this entire week, there were like totally lectures, five lectures. So totally there were five sessions in that. The first session was basically the brief introduction about the municipal wastewater treatment. The next session was specifically based on screening. The next session was based on grit removal. And the last two sessions were based on the primary sedimentation. Okay, so this is the overall thing they have like been taught for the week. So now I have some questions, so we can like solve it together. So the questions are basically I have like three different type of questions. The first one is screening based. The third one is primary sedimentation based. Okay, so apart from this, one or two theoretical questions also I have based on the treatment chain and everything. And mostly the professor had like spoken about the theory last week. So the problems in the weekly assignment was just two problems. One was based on the screen design and the other one was based on the primary sedimentation tank design. So like however I have included this grid chamber design based problem also, like simple problem. So now let's proceed with the problems. First I will like share my screen and show the PPT so that you can copy the question by the time, and then um, we will solve it together. Is my screen visible? Can
Yes,
you
ma'am.
Can you all please note down the question? A treatment unit is 2 meter wide, 30 meter long, and has a wastewater depth of 3 meter in it. If the wastewater flow through the tank is 0.6 meter cube per second, calculate the detention time in minutes. It's very simple problem. Does anyone know the answer or how to solve it? Okay, I'll give 1 or 2 minute time. Maybe you can think and then like tell me the answer if someone knows. Now time in my clock is 9:41. So at 9:43 we can discuss. Is that okay? It's very simple problem. It won't take even 1 minute to solve. Is it okay? I will tell the formula. Q is equal to V by T. Okay? That is flow is equal to volume divided by time. You have to find what is the time. Okay? and in minutes. You just have to you'll be getting the time in seconds when you substitute everything, and then when you convert it into minutes, you just have to put divided by 60 and then you will get the answer. Did you people understand what am I telling? Pavitra, did you understand? Okay, I'll just solve it directly better. Is my iPad visible? Okay, it's visible. Okay, so what is given in the question? Given dimensions of the so the formula is Q is equal to volume by time divided by detention time. Therefore, 0.6 meter cube per second is equal to volume is nothing but 2 into 30 into 3 divided by dt in seconds. Okay, so dt in seconds is equal to 2 into 30 into e divided by 0.6. 1 time 0.3 times means this will become 1 time. So this is 0.1, which is equal to 300 seconds, which is equal to 5 minutes. So the answer is 5 minutes. Did you people understand what I am telling? Did you people understand what am I telling? Okay. So shall I go to the next question then? Shall I go to next question?
Yes, ma'am.
Okay. Is my screen visible?
No, ma'am.
Okay. Now is the question visible? Next
Yes,
question.
ma'am.
Okay. Okay, we will go to the next question. Maybe we will solve problem itself. Okay, so next problem is in an upflow clarifier, the influent flow is 400 meter cube per second, and at a certain point, the cross-sectional area of the um, clarifier is 40 meter square. Calculate the velocity with which the water is rising upward in the clarifier. Okay, so here for this question, it's question number 2. Please note down. Calculate the velocity with which the water is rising. We have to calculate the velocity. Q is equal to A into V, right? Flow is equal to area into velocity. So we know the area is given. We know the flow is given. We just have to find the velocity, which means velocity is equal to Q by A, which is equal to 400 by 40. Did you people understand what am I talking? Okay, let me share them. Can you solve it? It's very, very simple. Nothing huge. Yeah. Please solve. It's very simple. Nothing very dramatic or anything. Given Q is equal to 400 meter cube per second. Area equal to 40 meter square. Q is equal to area into velocity, which is equal to 40 into x. 400 implies x is equal to 10 meter per second. So the answer is velocity is equal to 10 meter per second. Yeah, very good. Yeah, very good. Super. Okay, so now next question we will move. Yeah, it's correct. Chandra and Pavitra. It's correct. Now I will share the next question. So yeah, the answer is 10 meter per second. Okay, so the next problem is design a primary clarification system for a designed average flow of 7570 meter cube per day. Assume the estimated BOD removal is 35% at the design flow. Assume the overflow rate is 28.5 and 28.5 meter cube per meter square per day. So the first step will be to find the dimensions. The second step will be to find the detention time. Okay. So how do you find the tank dimensions? What happened? Screen not visible. Oh, okay. Now is it visible? Is it visible now?
Yes, ma'am.
Okay. Please copy this question and try to solve. We will discuss in 1 or 2 minutes. Okay. So given is, just note down the given. Q is equal to 7570 meter cube per day, and BOD removal is 35%, and assume the overflow rate is 28.5 meter cube per meter square per day. Okay. Have you all noted down? Shall I move to the solution? Okay, I'll give one more minute. Please copy the question so that it will be easy for you people to follow. Given flow rate is equal to 7570 meter cube per minute, and then we have our POD removal rate is equal to 35%, and then the overflow rate is to be assumed as 28.5 meter cube per meter square per day. Okay, so now first we have to determine the tank dimensions, and second will be the detention time. Okay, so let me share my iPad screen. Okay, so treatment, the second problem. Sorry, this is third problem. Second, somehow managed to enter the meeting. Tank dimensions 18.5 meter and detention time is 2.5 hours. 1 second, let me check the answer. Let me come to that point. Okay, so first is what is the surface area you have got, Chandra? What is the surface area you have obtained? From the surface area only we can determine the dimensions, right? Okay, 265. 265. Okay, how did you get the surface area? Okay, fine. Let me show my answer. Okay, let us solve this. Like how I have solved, I will just tell. It's yes, correct. Overflow velocity in the denominator divided by the flow. Yeah, that's right. That's right. So yeah, okay. Okay, so let me solve this in way. Okay, so overflow velocity is given in the question as 28.5 meter cube per meter square per day. This is meter cube per day. So when we put Q by overflow velocity, we get the required area. Okay, so Q here is 7570 divided by 28.5, which is equal to 265 meter square as told by Chandra. Okay, so now we can assume L length to breadth ratio as maybe 4:1. Okay, in that case 4x square is equal to 265. This will be 4x, this will be 1x. Length equal to 4x, breadth equal to x. Okay, so 4x square you will get, implies x is equal to, it's nothing but calculator, 265 divided by 4, just nothing. Okay, and then we have to take square root, which is not 8 point, x is equal to 8.13, implies 4x is equal to into 4, 32.55. Okay, so this is length and then this is width. So now we should know the depth, right? Depth we can maybe assume as 3 meters. Therefore, dimensions of the tan equal to 32.55 cross 3 meters. Okay, so now we have to determine the detention time. Detention time equal to flow divided by volume of the tank. Just nothing but 7570 divided by 32.55 into 8.13 into 3, which is depth, which is equal to 7570 divided by 32.55 divided by 8.13 divided by just nothing but 9.5. This, that is the detention time. Okay. Okay, so now let's move to the next question. Is it clear for everyone or should I explain it again? Can someone respond? First, what we have done is,
Yes, ma'am, it is.
okay, fine then. Okay, first we have like found the um, area because all other this flow rate and uh, overflow velocity are given, so we know what is the area. From area we assume the length is to breadth ratio, and then we assume the depth is 3 meter, and then find all the dimensions of the tank. Then when you know the dimensions, q is equal to v by t, so volume you know, t is equal to v by q by v, which is equal to 9.5 days. Okay, so now let's move to the next question. The next question is, let me share my screen. Okay, so this question is, determine the head loss for a rack provided with rectangular block of thickness 1.5 centimeter. Minimum clear spacing between the bars is 5 centimeter. The velocity of flow approaching the rack is 0.3 meter per second. Angle of inclination of the rack to the horizontal is given as 30 degrees. So determine the head loss for a rack. You have to find the head loss, okay, in this question. So I will solve this question. Question number 4, given rectangular block of thickness question. Okay, let me share the question again. One second, let me share the question. Is the question visible now? I'll give 2 minutes time, you can copy the question. Okay, I will give 2 minutes time. Yeah, okay. No worries, Chandra. And just copy the question. Did you all copy the question? Shall I start solving it? Or you need 1 or 2 more minutes to copy the question?
2 minutes.
Okay. Take your time. Shall we solve? Did you guys copy the question?
Yes, ma'am, please.
Okay. Okay. So given in the question is 1 second. Okay, 2.4 mm. Okay, let's check here. 1 second, give me 1 minute. Let me check the answer. It's 1.11 meters. Okay, let's just solve it. That should not be a problem. Okay, so minimum clear spacing is equal to 5 centimeters. And then the velocity of flow approaching the rack, approach velocity equal to 0.3 meter per second, and angle of inclination of the rack to the horizontal equal to 30 degrees. Okay, so now the formula is H is equal to beta into W by V the whole power 4 by 3 into V square divided by 2G into sine theta. Okay. So the beta value is 2.42. It should have been given in the question. Beta equal to 2.42, and then W by B. Okay. So W is the thickness divided by the breadth, which is nothing but the spacing. Okay. So it is 0.015 divided by 0.05, the whole power 4 by 3 into approach velocity is given as 0.3 meter square per meter per second. So that divided by 2 into 9.81 into sine 30 degrees. Can someone solve and tell me the answer? I will give 2 minutes time. Okay, I will wait for 2 minutes. It's just substitution, but can someone solve and tell me? So it is 2.42 into 0.051, 0.015 divided by 0.05, the whole power, we have 4 divided by 3.
Now it is 0.001 meter.
Yeah, that's right, 0.001 meters. 0011 meters or 1 meter. Okay, so that's all with this problem. It's just direct substitution, but beta value is 2.42. That should have been given in the question, and then nothing else. It's just very straightforward substitutions. Okay, so now let's move to the next question. Okay, so the next question is, design a core screen and calculate the head loss through the rack using the following information. The peak design, okay, the peak design wet weather flow is equal to 0.631 meter cube per second. Velocity through the rack at peak wet weather flow is equal to 0.9 meter per second. And then we have velocity through the rack at maximum at maximum dry weather flow is 0.6 meter per second, and the angle of inclination with the horizontal is given as 60 degree with mechanical cleaning device. Upstream wastewater depth is equal to 1.12 meters. Okay, please copy the question. I'll give 2 minutes time for copying the question, and then we can solve the problem. It's easy only. Is that okay?
Yes, sir.
Did you all copy the question? Can we solve it?
Yes, ma'am.
Okay. Okay. So in this question, the given data is you are given with the peak flows in both the seasons. One is the wet weather flow, other one is the dry weather flow. So peak flow in both the seasons is given, and then you have the velocity of approach and approach velocity, and the velocity through the rack is given, and also the angle of inclination is given. Okay, so we have to check which peak flow is higher. Okay, so wet weather peak flow is 0.631 meter cube per second. Okay, the other one, dry weather peak flow. No, I'm
Ma'am,
sorry.
this.
Yeah,
Depth of
only
water,
one thing is
right?
given. Yeah, I got it.
With the
Yeah, I got it.
depth of water,
Yeah,
I am asking about this 60 degree which is given with the mechanical device
Yep,
angle of inclination.
yep.
So how we can, can you get me understand? I could not get this.
Okay, wait. 1 second. We will come to that step. Okay, we will go step by step. Thing is, we have been given only the wet weather flow, and during the wet weather flow only, obviously the uh, peak flow is going to be high compared with the dry weather flow, because during the wet weather flow we will have all the what to tell, all the storm water entering, right? So obviously this will be high. So yeah, so in step one, that angle of inclination is given to calculate the height of the rack. We will come to that part. Okay, like that will be in the last step, so we will come to that part. So first step is we have to calculate the area. Okay, area is equal to peak flow uh, was I am I audible?
Yes, ma'am, you are audible.
Oh, I'm sorry. Actually, I was talking like after muting. Okay, I didn't know it was under mute. Okay. Yeah, we will come to that angle of inclination part. It's just simple thing. We will like use it for the for calculating the height of the rack. Okay. So now first we will start with we will go step by step. The first step is to determine the area through the rack. Okay. So for that, area the rack is equal to peak flow divided by velocity, which is nothing but 0.631 divided by 0.9, which is equal to 0.9. Can someone solve and tell me the answer? It's just division. 0.631 divided by 0.9.
And this is 0.701.
Yeah, 0.7011 meter square. Okay, this is meter cube per second. This is meter per second. Okay, so this is step 1. Second step will be step 2 is to calculate the width. Okay, so we know the area. Okay, we know the area um, of the opening, and in the question we have been given the depth of downstream water is given, equal to 1.12 meters. Okay, see here. Imagine this is the screen. Okay, so now this is the height of the water. Okay, so this is the height of the water, and it is given as 1.12 meters. Okay, now we need to find, we know the area of the opening. Okay, area of the opening is, one second. Okay, area of the opening is 0.7011 meter square, and now we know the height 1.12. Then we will know the width. Okay, so the width of the opening, the total width of the opening we will know. So the total width of the opening will be how much? 0.7011 divided by 1.12 meters. Can someone solve and tell me?
1.626.
Okay, 0.626. Yeah. Okay, so the next step is step 3. Okay, so now we have to calculate the spacing and the number of bars that we have to give to the rack. Okay, so if this is the rack. Okay, so
Could you please tell what we have area of opening? We had okay. See, in this rack we are considering only one opening. Number of openings are
no,
there.
no, no. We have to find the number of openings. Okay.
Okay, this is the total area of opening which you are
Uh, yep. See here, I'll just draw something so that you can understand. This is the rack. Okay. Okay. This is the rack. So we have to give the bars like this, right? We have to give the bars like this. We know the total width of the rack. It is 0.626 meters. So now we have to calculate the number of bars and the spacing. Okay. So if you, for that first we can choose the spacing of the clear opening. Okay. So the spacing of the clear opening, we can choose it as 25 mm. Okay. So now we know what is the spacing. Now we have to calculate what is the number of openings. Okay. So step 4. number of opening. So number of opening will be n is equal to 0.626 divided by 0.025 meters. This is also in meters. This one I have converted in meters.
On this 25 mm you have assumed?
Huh?
250 meter spacing of clear opening is
25 mm. 25 mm.
25 mm you have assumed?
Yep,
So
yep.
it is not.
Yep. Okay. It depends upon the type of screen you choose. Okay. Since it is given as a rack, we have like taken it as 25 mm. You can take maybe 20 mm, or like if it is core screen, you have to check the width of the core screen and then you can choose accordingly. Depends upon the type. Okay. So now I have assumed it as 25 mm. Okay.
Ma'am, could you please, since I was late here and I am not studying regularly, I'm just asking what is the difference between the rack and core screen? Because I'm in working this field only, but I
Okay.
have seen this, the core screen with racks. So that mechanical screen which I have seen is, that has a mechanical rack which collects the, dry putting material and takes it up and get it fall on the conveyor. So
Okay.
it is like this. And what is the here in the books? What you are assuming the rack and what is the difference between the core screen? That's what I wanted.
Okay, so my understanding is, thing is like I don't know like how it is like present practically, but my understanding is the difference between rack and core screen is the spacing of the opening. Okay, so rack is supposed to have a bigger opening and core screen is supposed to have a bit lesser opening compared to rack, and a fine screen will have still more uh, closer opening compared with core screen. So that's what is like my understanding, and like theoretically that's how I had been like taught, but I don't know like how like it gets operated like practically.
Yes, you're right, ma'am. But if we call it, see, in the canals, when we are using the bigger opening, maybe that may be 100 mm or 80 mm, 100 mm or more than that. That is a rack. That's I know. Rack is generally is fitted with vertically actually vertical rack and with 90 degree. And then when we are using core screen, that is with 75-degree angle core screen with 50 mm or lesser opening. And then with if we are using manual screen, then it is around 55 to 65 degree. So this is just small things I'm just remembering. So anyhow, I'll not.
Okay, actually, I took these questions like from book or like some reference materials, so I'm just following that. So I'm not
That's
like
very
sure
good, ma'am.
like
I am lacking of that, the book, studying the books that I am lacking. That is the reason I am here, get taught by you. That is the reason. Anyway, ma'am, please go ahead. So I
Okay.
can discuss my, problems, so that all other people may not get disturbed. Thank you.
That's okay. We can discuss. That should not be a problem because like I don't have much practical like experience like you. So yeah, that is the thing. So yeah.
Even
Okay.
I came only in the first class and I am coming today only due to
Okay.
personal things. But anyhow, I have studied only 10 lectures from the WhatsApp lectures. After that, I could not, regularize that. But I will try to make up that because I had a personal surgery and I am on bed rest. But anyhow, I will be recovering within 2 3 days because it is already 10 days. So
Okay,
no
take
problem, man.
care.
I'll be regular, and then only I can see these the questions which I am asking, which maybe are irrelevant to the subject which you are teaching
No,
the
no, no. It's not like that. It's not like that. It's not like that at all. Like thing is like I'm following the materials like which I have used for like studying during my PhD or my MTech. Okay, so like the theoretical questions which like were given in the lectures in my previous like classes, I'm using that.
Can I know which book you are following? Because I am doing Mathco already, but it is bit tough. So sometimes I take reference of that, sometimes I do not.
Yeah, actually Metcalf is like very good like for following like theoretical stuffs. But yeah, Metcalf is very good. Even I used Metcalf when I was studying. So yeah, you can actually follow Metcalf. Apart from
Okay.
that, yeah, Metcalf is like what to tell. It's like Bible for like these things for design and everything. So Metcalf should be
So
very
in
good.
which chapter should I study this? This which part you are getting me followed, so that I can go directly to that which I am being taught by you, so I can get it revised. Otherwise, I have to go to the Dr. Saab lecture. Kindly tell me the lecture number so that I can go to the notes, and I can go ahead with by step by step with you. That is my request.
Okay. Give me a minute. Let's check now itself. Metcalf. Let me share my screen. Okay. This is the Metcalf book. Hmm, we have to go to screen. Okay, here it is. 315.
I find this design of core screen installation. 320 pages, 320 number page.
Okay, 1 second. Three 20. Yeah, there is a sample problem over here. I actually have the very same problem in like today's class also, I guess. Maybe I have like changed a bit. mm yeah, I have a very similar problem. Yeah. Mm. Okay, you can use this as reference for like studying, or even the lectures should be okay. Like for purpose of scoring, the lecture content should be like more than enough. But for your knowledge,
One more thing I want to ask here.
yeah.
The lectures are openable in only this drive only, no? You cannot download the PDF.
No, you can download the PDF.
I'll try today because I think I don't have that, so that it's sometimes see actually listening is easier, but we must have the time. But since I have
You can download it. Wait, I will show you how to download. It's easy. I myself downloaded it. You can just download it. See here, week 5 is there, right? You go to the lecture material. Huh? Week 5 lecture material is there, no? Click on that, and then you can click on this download. That's it.
okay, ma'am, I go to that because sometimes this is a PPT, na, so studying, reading is also easier actually.
Yeah, you can use this actually. Yeah, you can easily download it. Like, yeah, even like now only I download.
I may be downloading on phone, na, so that's why I was not getting it easily.
Okay,
So
then I will
download
I can just share it in the chat so that you can just like give me 1 minute. Okay, where is the meeting? Oh no. Give me a minute. I lost the tab. Just close it.
Take your time, ma'am. A lot of tabs you have,
Yeah, that's what. Mm. Mm, mm. Okay, thing is, I'm not able to attach any files in the messages. So, mm,
No problem, ma'am. I got your point. I'll try to download. If I have any problem, I can ask you. I think I've taken your mail also.
yep, yep, yep.
I'll mail you for any queries.
Okay,
Thank you.
no worries.
Please go ahead for the, I have seen the book page also. So I'll go through that as well as a lecture.
Okay.
And from this chapter, you are referring the similar thing, na? This Medcom ID as well as the lectures. Although you are a PhD student, definitely you may be studying more, referring more books and maybe it's just or how. But
Yeah, anyway, I will share this PPT also, in the materials, so you can go through it. If you feel something is difficult, you can ask me. But thing is, um, mostly the assignment problems and similar to that will be coming in the exam from the exam point of view. Okay, but
right,
these questions I have taken, so that you will have some variety. Okay, because the other two lectures they'll be using the previous year questions um, given in the NPTEL assignments to solve. Okay, but then I don't want to give the same questions again and again, because if you attend two sessions you will be getting the same content. So that's why I thought I'll give take questions from my study material or something. That's why my questions are different. But if you feel something is difficult, you can ask me. But if you feel something is very different, then probably that won't be asked in the exam. Okay, it's just for your understanding purpose, because this questions only I am taking, and it's not coming from previous assignments or anything. Okay, so
one more thing I want to ask here. I have not done any of the assignments, so it is mandatory to do that.
Assignments is mandatory because it has lot of weightage in your last exam. Have you applied for the exam?
Yes, I have already applied, but how can I do the last assignments also, or it is already gone?
I think it's gone. Maybe from this week onwards you can do. Assignment has lot of weightage, so please focus on assignment questions. And even in the end question, in the end NPTEL exam, you will get similar questions to the assignment questions. So if you are focused in getting the certification, then assignments are mandatory.
That's okay, ma'am. But I have left a lot of them. What will happen?
That's okay. That's okay. Anyway, you can
It will
work
be
from.
covered. If I'll do from right now.
Yeah, from right now you can do. Yeah. But the previous assignments you can't submit. Only from week 5 you can submit, I guess.
These four assignment I have missed.
Yep.
From week 5, I'll be solving on the time. I'm getting the mail. Can you please help me? Week 5 assignment is till when we can, sir,
I think that will be given in the website itself, right?
you can check.
Mm,
Thanks a lot.
uh,
Valuable information, because this I was missing, and at the end I may be in trouble.
yeah, you should solve the assignments because it carries some 40 or 50% weightage in your certification. So it is mandatory.
Anyhow, I have missed 4 numbers, so that maybe reduce my weightage.
Yeah, yeah. From now onwards, you just try to solve everything. I think that should be okay.
Right,
Okay.
right. Thank you.
Okay. Mm, Okay, so let's continue with this problem. Sure. Okay, so the number of bars you will get is approximately 25. Okay,
Yes, ma'am.
I mean, sorry, the number of openings, it's not. mm, okay, that's right. So from this, number of bars will be equal to 24, because 25 openings are there. 1, 2, 3, 4, 5 openings means you will have 1, 2, 3, 4 bars. So which means number of bars equal to number of openings minus 1. Okay. So the number of bars will be 24 bars. And then we are choosing 24 bars with 10 mm 0.01 width and 50 mm thick.
Then week 5 is also released on 27. I think it is released.
Oh, released.
Assignment 5 for week 5 is okay. This is solution is not released. Assignment 5 is live. So I have to fill it.
Yeah, you have to complete it. You can check assignment 4 also. I'm not sure when is the deadline. You can check if it is open still. You can like submit it.
Assignment 4.
You can check. I'm not sure of the deadline.
It was till week is also released. Can you access the assignment has to be submitted before Wednesday 20th August. So it is already gone.
Okay.
So I cannot do this. But week 5 will. Anyway, this is a good morning for me.
Yeah. Okay. Okay. So now we can like. Okay. So this is done. Now the height of the rack has to be calculated. Okay. Getting confused with multiple things. Okay. So now the last step is 1.12 divided by sine 60 degree, which is equal to 1.1 meters. So that's it. Okay, so that's all with this problem. Now let's go to next problem.
could you please show the height of the bar last one? Which
Yeah. Sure. 1 second. Yeah. 1 second. 1.29 meters. 1 second. Yeah.
This is vertical height divided by sin 60 angle of. Right?
Yep.
This is hypotenuse, no?
Yeah. Because of the hypotenuse we are taking. Wait, let me draw it and show it. Mm, Sin 60 is equal to 1.12 divided by 8 meters. Height equal to 1.12 divided by sin 60. Okay, see here. So it is 60-degree inclined. Okay, we should know what is the height of the rack. That is the inclined height of the rack. This is what you have to find. That is the hypotenuse side. Okay, now you know the vertical height is 1.12 meters. Okay, so 1.12 divided by the slanting height is equal to sin 60 degree. This height is nothing but the height of the inclined height of the rack. Inclined height of rack. Okay. So inclined height of rack is equal to 1.12 divided by sin 60. Okay. So that's why we have got 1.29 meters. That's it. Okay. So is it clear?
No, that is coming 1.384.
What?
1.12 divided by sin 60 coming to 1.384.
Okay. Yeah. Maybe some typo error. We can, yeah. That should not be a problem. Yeah, that's correct. Because here where 1.4 around 1.4 and plus 0.6 we are getting 2 meters. Yeah, that's correct. Yeah. Maybe some typo error. Like that's okay. Okay. So now let's go to next question. The screen visible?
Yes, ma'am.
Okay. Mm, okay. So two rectangular settling tanks. Okay. Two rectangular settling tanks are 6 meter wide, 24 meter long, and 2.5 meter deep. Each tank is used alternatively to treat 1900 meter cube in 12-hour period. Compute the overflow rate, detention time, the horizontal velocity, and the outlet wear loading rate using H-shaped wear with 3 times width. Okay. Please copy the question. We will discuss the answer in 2 minutes. That is when my clock shows 10, not 10, 11 o'clock. Okay. Now the time is 10:58. You can just copy the question. I'll give 2 minute time. And then if you know how to proceed, you can start. Otherwise, you can wait for me. Is that okay?
Yes, ma'am.
Thank you. Did you copy the question?
Yes, ma'am.
Okay, we can proceed. Solving. Okay, given two rectangular settling tanks. Okay, with 6 meter wide, 24 meter long, and 2.5 meter deep. Okay, each tank is used alternatively to treat Q is equal to 1900 meter cube divided by 12 hours. Okay, which is equal to, if you write in terms of per day or convert it into per hour. Okay, so you can just convert maybe this into per day, means it will come as 1900 into 2 is equal to 3800 meter cube per day, or it will become 1900 divided by 12. 158.33 meter cube per hour. Okay, so now we know the Q. We have to find the overflow rate. Okay, to determine, we have to find what all things: overflow rate, detention time, horizontal velocity, outlet wear loading rate. Okay, and that's it. So first we can calculate the surface overflow rate. V naught equal to Q divided by area, which is nothing but 3800 meter cube per day divided by 24 into 6. This is the area, that is length into width. which is equal to, can someone solve and tell me 3800 divided by 24 divided by 6? Okay, so the answer is 3800 divided by 24 divided by 6. The answer is 26.38 or approximately 26.4 meter cube per meter square by day. Okay, so this is step 2. Now step 3, you have to calculate the detention time. Detention time. Okay, first Q is equal to, oh, I'm sorry. Yeah, Q is equal to volume divided by detention time. Here we have 2 tanks. Okay, so 2 tanks means 2 into the volume of 2 tanks is nothing but 24 into 6 into 2.1. Okay, divided by detention time is equal to 3800, implies detention time equal to 2 into 24 into 6 into 2.1 divided by 3800, which is equal to 2 into 24 into 6 into 2.1 divided by 3, which is equal to 0.159 days. Okay, so T is equal to, we convert into hours into 20, which is equal to 3.31. Okay, so this is step 3. Step 4 is to calculate horizontal velocity. Horizontal velocity is equal to Q divided by the other area, that is depth into width, which is equal to 3800 divided by 6 into 2.1, which is equal to 301 meter per day. Okay, so the last step is step 5, to calculate the wear loading rate. Equal to 3800 divided by 6 into 3, which is equal to 211 meter cube per meter day.
Could you repeat this beer loading rate,
Yeah, 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 yeah.
length of beer which you
Yeah. Sure. One second. Let me show the question. Okay. So, um, the outlet weir loading rate using a hut-shaped weir with 3 times the width. Okay. So, the width of the weir is 3 times the width of the tank. Okay. So, if this is the tank, okay, this is going to be the width, right? So, this is the width. Okay. Now, our weir, that is like which is going to distribute from the tank, has 3 times the width of the um, width of weir, equal to 3 into 6 meters. Okay. So, weir loading rate is, the formula is Q divided by the length of the weir. Okay, Q divided by the length of the weir. So Q, you know, 3800, and length of the weir is nothing but 3 times the width of the tank. Okay, so 3 into 6. That's how we are
ma'am,
getting this.
ma'am, I want to interrupt here. Can
Yeah,
you show me the class slide with which you have drawn the tank?
one second. No, I have just shown the tank, not the weir.
Just a minute, ma'am. See, this is not the rectangular weir. This is HCF weir. I'm not remembering, but the rectangular weir, that whole bit will be fitted with the this one maybe horizontal strip of metal, or that will be a width of wall, actually overflowing. But here, this is written as 3 times the width of the tank. So here the width of the
No,
tank
I
is
was just showing the width of the tank. I was just showing the width of the tank, not the width of the weir. It was, I was just showing the width of the tank, not the width of the weir. Yeah,
that's
you are
okay,
right.
but how we can install the 18-meter long weir? Okay, this is H shape. Means this is three at three places. H shape is the vertical. If we see in the uh, plan of the tank, there will be three places. It will be falling the water. Means the horizontal one, and H shape is three sides. There is 6 meter each. That shape maybe I understand this, but this is the rectangular weir only, na?
It is given hut-shaped weir in the question.
That's okay, ma'am. Can you draw this shape weir? How it will be?
I don't have any idea about it, frankly speaking. I just took the
I can
question.
draw, ma'am. Can I share my screen, ma'am?
Yeah, sure, definitely. I
Would
would
I be
like to
able to
see.
share
Yeah,
my screen, ma'am?
you can. Wait, let me stop sharing.
Just a minute.
Yeah, I have stopped sharing.
Just a minute. I am sharing my screen.
Yeah, okay.
I would be drawing it on the AutoCAD, and I'll show you how it is generated. I
Okay,
can show the tank also, how we are placing this. What I understand, just you have to validate that my understanding, that's it.
okay,
That's what my motto is.
okay.
Just
Okay.
Are you able to see my window?
Yeah,
There is
yeah,
a
yeah.
black, this
Yeah,
one.
yeah, yeah. I'm able to see it.
It's a typical grid chamber, which we call detritus,
Okay.
and it has a this one straight view here. You can see the section. I don't know. I don't have it or not. See, this is the weir. The water is coming through this. This is the inlet side and this is the outlet side. Water is falling here into the outlet chamber. Who's here? So this whole wall is a working like a weir, and the water is falling like this.
Yeah, I got it. I got it. I got it.
Got it. And I think what I understand is in your problem it is shown like this. This is the rectangular tank
One
and
second.
this is the this one this partition and this is the weir. This should be the weir actually, but that may be the F shape means that outer chamber may not be rectangle like this. That maybe weir we can make of any shape. What I understand is the outlet chamber maybe this is this is the length, this is one, or this is one. So if these are the three sides, the water may be falling just a minute, like this, like this from here to here. Just a minute.
Mm.
Here to here, water is falling, and then it is falling here to here also. In three sides it is falling.
I
That's
got
what
it. I got it. Yeah, I got it. What you are like coming to tell.
here and here also.
Yeah, I got it. I got it. What you are like telling.
This is that's what I'm understanding. That's that may be the H shape. See this is
That's okay. Mm, yeah, but how this will be head shaped? I don't know.
this is not H shape actually. This is now C shape.
Yeah, this is she shaped.
See, water is coming and it is going out here, here, and here.
Yeah.
H shape may be like this. Chamber may be like this, and the water may be falling here also.
Okay, I got it. Yeah. Oh, yeah, yeah, yeah. I got it. I got it.
That may be falling like this, and all the tank is closed every side. This is the if I show you the boundary. So this is the only chamber where the water is coming in, and
And this is
maybe
like going out.
it may be going out like this here.
Yeah. Okay. Got it. Got it. Got it.
That's what this may be the ancient, this is my view.
Okay.
Otherwise, generally, no, I have one example of that. I can show you that. Not H, but that may be just a minute. I'll show you.
Okay.
Are you able to see my window AutoCAD? Black
Yes.
one?
Yes. Yes.
Just a minute. It's in under opening. I'll show the figure. This is
Okay.
also a grid chamber vortex type. Which is so built by Now are you able to see this?
Yeah, I'm able to see.
See this weir long 4 meter type you are seeing now.
Yeah.
So where the water is coming through this grid chamber, it is exiting out, it's coming through this channel, and it has to be fed to the some two number of clarifiers. So
Okay.
here the made the shape of the chamber. This is a rectangular chamber, but
Okay.
now to increase the weir length, we have made it L shape like this.
Got it. Got it. Got it. Yep. Yep.
Water is falling from here, here, and here,
Okay.
and after that, there are the sluice gates. After that, this is a common chamber. From here, this is a common chamber where we are distributing this to one clarifier here, another clarifier here. I can show you this one also. This is the layout, of this one. See, this is going like this. Are you able to see this?
Yeah, I'm able to see.
So this is the coming here, and VM arrangement, where the VM arrangement here, and it is going like this.
Got
Got my
it.
point or not?
Yeah, yeah, I got it. I got it.
So this is the this is the VR arrangement we generally make it, but anyhow, if this is a problem through Metcalf already, you can share me the page. I can go through that. I can understand what the author is want to represent. That's what I do.
Yeah, okay. This is not from Metcalf. This is like from my MTech like notes which my faculty shared. So I'm not sure like from which book he took it or like not. But
That's
yeah.
okay, ma'am. But the VR shape, what they have assumed, you can ask them, or you can just how their if our assumption is okay or their assumption is somewhere else. That's what I want to see. I had shown like this.
Yeah.
It may be going like we may have installed some pipe here, and it is going like this.
Okay. Okay, I'll see. I'm not sure like if I can like contact him because like I don't know because like now I'm doing PhD. It's been like more than 3-4 years like when I did my MTech. So I'm not sure if I can contact him. But from my end, if I'm able to like figure out some other like image or something like trying to if I'm trying to like if I'm able to visualize something, then definitely I'll like share it with you in the next class. Is that okay?
Yes, that's okay, ma'am. Just I wanted to share my feelings that it is like this only. See, whatever you want to communicate, so that should be reaching to us in a similar form. That's what I want.
Okay, okay, okay. Yeah, no worries.
That's what
Yeah,
I've taken your time, please.
yeah, yeah. No worries, no worries. Yeah, that's okay. Yeah, we
Thanks a
can
lot.
proceed with yeah.
See, I have been working in this field for last long time, but I could not have the opportunity to read the books. I have just completed my MTech also. The
Okay,
result is available with the this one by accepting my time to the job.
okay,
But still, I am working on revising the things so that I can go further for my PhDs and all that whatever.
okay, 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 okay. Yeah, 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 yeah. Sure, 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 sure. Yeah.
Right.
Thank you. Okay. So yeah, moving to the next one.
You can share this problem. It was in between. I have disturbed you all. Sorry to disturb you,
No,
but
no, that's totally okay. That's totally okay. Yeah. One second. Mm, yeah, I have just two more questions. We will like wrap up quickly because like the session should be over by 7, right? This is like very like straightforward question. It is similar to the question that is present in the assignment. So in the equation for estimating the terminal settling velocity, Vt is equal to
your voice is cracking. I think some network problem.
okay. Mm, is it clear now?
Yes, so it is clear now. Please.
Okay. Okay.
Could you please repeat that?
Okay. So in the equation for estimating the terminal velocity Vt, g into rho p minus rho w into d square divided by 18 mu. What does d and g refer to? Okay. So this is a very straightforward question, and I think you all know the answer. D refers to the
Then,
diameter. Yeah. Yeah, that's correct. Yeah, D is
then
diameter.
could you please explain this terminal settling velocity? This is for what? That's okay. The terminology you are asking that is straightforward, away, easy. But that is for what? Can you explain me in one or two lines, please? Just
The terminal settling velocity. You are asking what is the terminal settling velocity or something. Uh, Dinesh, could you please tell exactly what do you want me to explain?
ma'am, I want to explain you. This is the terminal settling velocity for maybe some clarifier.
Yep.
And
This
what
is
does it mean? What does it mean? What is its significance? That two question I have. Could you please, explain?
significance. In sense what sort of significance I'm not getting your point.
You can straight away tell me the definition of terminal velocity here so that I can understand what is the use of it while designing it clarifier. That's what I.
Okay, just give me a minute.
And your voice is gone.
Yep. 1 minute. Okay, this terminal settling velocity, we use it in the uh, discrete particle settling. Okay, Dinesh, I request you to watch the lectures, please, because I think in the lecture it is explained, and also I mean, I'm not demeaning or something, but I have to wrap up the session within 4 minutes. I still have some more questions to I had prepared more questions. So I
That's okay, ma'am. I'll go to that. You can please go ahead. Thank you.
yeah. I'm really sorry, but yeah, it comes in the discrete particle settling. Okay, so it comes in the discrete particle settling, and we use it for finding the we use it for designing the sedimentation tank. Okay, so while designing that uh, sedimentation tank, we make some assumptions. Okay, so in that the first assumption is the particles for which, if the particles are discrete, we use this one. Okay, we use this formula. Okay, this Vt into g into rho p minus rho w into d square divided by 18 mu. Okay, so how we
Thank you.
actually solve the problem is 1 second. Okay, so this is for laminar discrete particle settling. Okay, so if you know the approximate diameter of the particle to be settled, in a sedimentation tank, Then from that, you can get the VT and then use it as a surface overflow rate for designing the sedimentation tank. This is the overall idea. Okay, so when you know what type of what is the diameter of the particle you want to settle down, then from that you will know the VT, that is the time, the velocity at which it will be settling. So from that you use that as a surface overflow rate and then design the sedimentation tank. This is the overall idea, how you have to see. But I suggest you to maybe at least go through at least this lecture number. I will tell the lecture number. It is lecture number 4 and 5. Lecture.
Thank you, ma'am. I'll go through the lecture number 4 and 5, week 5, na?
Yeah, especially 5. Yeah, week 5. Week 5. This is for this settling tanks the professor had handled. So maybe I can mail you the exact timing also, like from which to which you want to you have to watch it. Like maybe you can type your email ID. I will just check exactly which lecture and which time you have to see to understand this concept. Is that okay?
Right, ma'am. Thanks a lot, ma'am. I'll write my mail ID.
Yeah. You can write the mail ID. So yeah, I think we can wrap up today's session because it's already 2 hours. So yeah, we can discuss maybe the other questions quickly. It's just theoretical questions in the next class, next session itself. Okay, is that okay for everyone?
Yes, ma'am.
Okay, thank you. So your mail ID is 19010 C029 55 civil is you, right?
Yes, ma'am.
Okay.
This is Dinesh, ma'am. Dinesh.
Okay, Dinesh,
Dinesh,
you can write your mail ID.
mail ID. I am searching the text box, ma'am. It's there. Where I have to write it, should I?
Okay. Or you can just tell me. Or you know my mail ID,
Dinesh.
right? You know my mail ID, right? You can just send an
Yes,
email.
I know your mail
Yeah.
ID.
You
The
can
last
just
class
send
I
an
noted it.
email to my mail ID. Yeah, I will respond. Yeah. Okay. Thank you.
Right, Sita, ma'am.
Thank you.
Thanks a lot.
Thank you so much, Dinesh. Thank you. Bye bye.